Okay, guys, a very warm welcome to my lesson for today. I think we are all set. So what I'm going to do now, it is to prepare to share my screen. Once my screen is sharing, then we continue. So today it is a physical sciences lesson, meaning we are going to be continuing with what we started the previous time. Let me do that. Okay, then it's fine. So guys, I'm about to share my screen. Once that is done, I'm going to confirm with you guys if you are able to see my screen. And upon confirmation, we will then continue. So let's see, guys, can you clearly hear me? Can you clearly see on my screen? Yebo noma cha? Guys, are you able to clearly see on my screen? Yes, yes. Okay, then it's fine. Let me say it all and then I'll say no. Let's see. Ethan Moore, I think I'll make you the co-host. I'm pretty much sure that you do know the rules. Meaning, just in case if I'm starting to break, otherwise, in case if the screen is no longer sharing, all that you need to do is just to unmute yourself and let me know. Only in those cases. In case if I'm asking a question, don't be tempted to unmute. When it comes to the questions, I will have to unmute everyone. So guys, electric circuits is what we started on our previous lesson, and we're going to be continuing with that topic. So very quickly, if you guys remember, we said we've got these formulas that we use. The one that we use to calculate R total being R tot, which is equals to, you take R1, you plus it with R2, you plus it with R3, you plus it with any other resistors which may exist on an electric circuit. And then the other formula that we normally use is the one which says V, it's equals to IR. And we also spoke about this formula that we use to calculate R parallel. And we said it is 1 over R parallel, which is equals to 1 over R1, that you plus it with 1 over R2, you plus it with 1 over R3, you plus it with any other resistors which may be connected in parallel. I will give you guys some examples. Let us say we have there it is a battery, and then there it is a conducting wire. We have a resistor there, we have a resistor there, we have a resistor there. Maybe this battery, it has, let's say, electricity of 20 volts. And then we've got a fridge there that has 3 ohms. And then we have TV there that has 1 ohm. This is your cell phone. It has 0.5 ohms. So this is an electric circuit where you may be asked some questions. Remember, we said for us to know the amount of current that is flowing in that circuit, we can just connect an ammeter there. The ammeter will tell us how much of electricity or how much of the current is flowing through that electric circuit. It's like the conducting wire is a hose pipe. So the ammeter is trying to tell us the amount of water that is flowing inside that hose pipe in yellow there. Can you see? So that means that ammeter, it's either you put it there or you put it there. You can put it there or there or there or there or there. Wherever you put it, all we know is that it is just going to read the same amount of water because this hose pipe is the same throughout. Is the same throughout. I will show you the cases where it is no longer the same. That's when it splits. That's when it creates a parallel connection. Let me draw that just now so that you've got an idea. So in a situation where you have that battery there, and then now instead of having that line, it does that. Okay, we have that 20 volts there. We still have that one of 3 ohms there. And then we still have that one of 0.5 ohms there. Then, instead of having that one of 1 ohm, which was connected in series, now we have made a parallel connection there. And that parallel connection, it can, for example, have, let's say maybe, again, it has 1 ohm there and it has 1 ohm there. So now, think of this line as a hose pipe starting from there. This is the hose pipe. Same amount of water, same amount of water, same amount of water. When it gets there, that hose pipe, it splits. It creates a T junction. Let's say this is that hose pipe. And then now it does that. Now it does that. So can you see? That means this current being the water, when it gets there, you know that song, most honorable members. Meaning, not all this current, not all this water will equally share. It will depend. So that means the other amount of water will go to this side. The other amount of water will go through this side. When it gets there, it joins and then it continues with the same amount. Then it continues, it splits, it joins. Splits, it joins. That's what it does, honorable members. And the reason why you can have this type of a connection, it is so that this room has its own light bulb. And then this kitchen, it has its own light bulb. So that when you want to switch off the light in the room, it doesn't switch for the whole house, but just for that room. That's why we would do parallel connections. Okay, so now, if you want to know whether too much current will go through the side or through this side, how are you going to know? It is the resistance that will give you that indication. So can you see this side is 1 ohm? Also this side is 1 ohm. So that means since it is equal resistance, it will split equally. The current will split equally. But let's say this side it was 4 ohms and then this side it was 10 ohms. So this side you have little resistance, meaning more current, more water will flow through that side. But on this side, you have too much resistance. So that means very little will flow through that side. Think of it this way, honorable members. You have 10 soldiers on this side. You have 4 soldiers on that side. Which side are you going to go in order to pass through? You'll obviously try your luck on this side because there are very little soldiers, meaning more will flow through that side, but very little through this side because there's too much resistance here. You won't easily pass because there are too many soldiers. So that's how you interpret the flow of current. We haven't done any calculations, but we're about to do some calculations now. But before we do that, let me just check if you guys understand this scenario, because if you fail to understand this part, it won't be easy when it comes to the calculations, because they are based on this story of you understanding that you have a battery and you have resistors there. These resistors can be connected in series or parallel. The first part, they are connected in series, all of them. That one in series, that one in series, that one in series. But here we do have a parallel, even though others are connected in a series. So now let's see. Which ones are connected in series? That one is connected in series, but where you have that conducting wire splitting, this is where we say that in parallel and that in parallel. Let me check. Guys, what I've just explained now, does it make sense? Or anyone who's got some questions for me on that part that I've explained? Ningasabi. Then, Puikanyo, Tui, Katleho, Kanya, Tolom, Manga, Shonisani. We have viewer there and Zoom user. Guys, any questions for me? I am asking all of you guys to unmute and let me know if you've got some questions for me. I'll be waiting. I will be waiting. It looks like all of you guys are confirming that you do understand. I am well aware that all of you guys are going to be doing this topic for the first time. Great. Okay, just hold on. I just want to quickly do something. I'll be back. Okay, guys. I did get a confirmation from all of you guys saying that you do understand that part. Let us now come to this part of the calculations. Let's say we have that there. Maybe let's start with this one. And then I'm going to put a resistor there. Resistor there, resistor there. Put another resistor there and say, I will say we have 20 volts there. Maybe here, let's say we have 2 ohms. We have 1 ohm, 2 ohms, and then we have that. Let me connect an ammeter, honorable members, just so that we can try to know the amount of current that is flowing. There I've connected an ammeter. Okay, so now, let's see. The questions that may come, they may say, question number 1, calculate total resistance of the circuit. And then question number 2, they can say, reading on ammeter. It's like now they want to know the amount of a current that is flowing, that is passing through that ammeter. So when they say calculate the total resistance, or they can say the external resistance, it doesn't really matter that much. The external resistance or the total resistance. You just need to know the formula to calculate R tot. The formula to calculate R tot is only one formula to calculate R tot. And it's self-explanatory because R tot, the tot means total. In other words, you must total all the resistors. That means you must take R1, you must plus it with R2, you must plus it with R3, you must plus it with all other resistors which may exist. In this case, we have 1, 2, 3, 4, meaning we are going to have up to 4. The first resistor, it is 2 ohms, that you plus it with 1 ohm, that you plus it with 2 ohms, that you plus it with 3 ohms, that is 5, 8. So that means total is 8 ohms. Yes, that is 8 ohms. That's how you would work out that first one. Maybe let me jump on to the next one, which says the reading on the ammeter. So you must always know that this is where you will now use that formula which says V is equals to IR. Always, when they want you to calculate the reading on the ammeter, it is actually that I, which is the current. I means the current. We measure the current using an ammeter. So that means every time when they say, what is the current flowing on that circuit, then you use that formula and you know that it is the I that you'll be looking for. Otherwise, if they say the reading on the ammeter, it is that formula that you use and it is the I that you're looking for. When it comes to R, it's easier if you need to find R using the formula. And then when it comes to this one, it is the voltmeter or the potential difference. It is the potential difference that they can say calculate. It is actually that V that they want you to calculate. Sometimes they can say the reading on V, meaning they can connect V on that device. It could be a stove. So it's like they want to know how much of electricity is being taken by the stove. If they want to know how much of electricity is being taken by that generator, for example, or the geyser, then they will connect it across the geyser. If they want to know a V across that one, they will put it there. If they want to know the reading across that one, they will calculate V there. So that means, for example, if this one, it takes 5 volts, that means from that 20, the stove will only chow 5 volts. And then you may find that maybe this one being the geyser chows too much electricity, maybe it will take 10 volts. And then you have this one, maybe it can take 3 volts, maybe it's your microwave. And then this one is your phone, maybe it takes 2 volts. Yeah. At the end of the day, when you take that electricity chowed by that electricity chowed by that electricity, when you add all of them, they must take you back to that electricity of the house. That's how it works, honorable members. So now let's calculate the reading on the ammeter. We just said it is that formula that we are going to use. Meaning we say our V is equals to IR. Trust me, I already know the electricity for that circuit is 20. How did I know? It is that one that we were given there. All of these were just examples to say if this goes there, that goes there, that goes there. Yeah. So it is the I that we are looking for. What is our total R? We just calculated it is 8. Then that means our I, to calculate it, you just divide everything by 8. Why did you divide by 8? So that this cancels with that. Then you just remain with your I, which is what you're looking for. And then you have 20 divided by 8, which is equals to 2,5. The I is measured in amperes. So every time when you get an answer, you say A. So that means that V is measured in V, that one is measured in A, the amperes, and then this one in ohms, the resistance in ohms. So that's how you would work out those two questions, honorable members. Very quickly, let me check if you all understood before we go deeper. Let's say, any questions from your side? Or are we okay, all of us up to this point? Ningasabi, honorable. Okay, no question. Okay, then it's fine. It is fine. So now let's maybe let's look at this type. Let's look at that. I'll connect A there. And I will do that. Again, I would say 20 volts. I will say 1 ohm there. This one, let's say, is 2 ohms. That one there is 3 ohms. Okay. So now, again, let's calculate number 1, R taught. Number 2, a reading on that ammeter. Okay, let's start with R taught. The question is, what is the formula to calculate R taught? I said it's only one formula to calculate R taught. We don't have two, we don't have many, it's just one. And the formula says R taught is equals to R1, you plus it with R2, you plus it with R3, you plus it with any other resistors which may exist. What I know is that in this case, I only have that one of 3 ohms that I need to plus it with. I still have those ones which are connected in parallel. So in this case, you cannot include that one and that one on the formula. Why? Because they are not connected in series. So that means this formula, you use it for when the things are connected in series. That's why I only substituted that one alone, which is that one there. So that means I need to convert this parallel connection into a series connection. How do I do that? That's when you use the formula for the parallel, which is 1 over R parallel is equals to 1 over R1, you plus it with 1 over R2. So that means you have 1 over R parallel, which is equals to 1 over, you can start with 1 or you start with 2, then 1 over 2. So the first step that you must do, you write the formula, you substitute. Last step, you just say R parallel is equals to. You rewrite these things exactly as they are, but you just say to the power of exponent -1. So that -1, what it does, it is actually, can you see this part? It's 1 over, but we don't want 1 over, we just want that R. So this is that R. So to remove that 1 over, you remove it by doing that. For now, understand it as I've explained. Later, it will make perfect sense when we are dealing with some more problems, especially related to maths, because here I'm just using maths tactics to work it out. So if you punch this audio calculator, if you punch that, it gives you 0.67 ohms if you round it to 2 decimal places. So what you have done, honorable members, what you have done is like you have converted this connection, you've converted that connection into a single connection of 0.67 ohm. It's like you cancelled that parallel and you converted it into a series. Why did you do that? Is so that you can substitute it on this formula so that you know what is your R taught. So that means R taught will be equals to that 3 plus That's 0.67, which is 3.67 ohms. That's how you calculated your R tot. That part now, it is done. Before I calculate the reading on the ammeter, I'll actually give it to you guys to calculate it. But do you guys have any questions for me on that part that I've done regarding R tot? Ask all to unmute. Guys, you tell me. Any questions for me on that part? Guys, don't be scared to say you do not understand. Guys, okay, there you've got some comments. Let's see what you guys are saying. Makes sense, makes sense. Okay, okay, okay. Then it is fine. It looks like we are okay. Okay, then it's fine. Now it is your turn to calculate the reading on the ammeter. Work out that part and then comment in the comment section with the value for the reading on the ammeter. Let's see if this thing is going to write. Okay, it's fine, it's writing. Okay, let me quickly go put this electronic pen on the charger. When I come back, I will check your answers. That means you've got just 2 minutes on that. Okay, guys, let's see. No comments. What's happening, guys? Are you still working it out or is it difficult? Please do let me know. Is it difficult? Are you still working it out, or what's happening there? Just want to have an idea as to whether you guys understand how to work it out, or if it's difficult. Then I will know what to do. Okay, let me check the comment section regarding what's happening there. Okay, there's someone who's got an answer. Okay, then it's fine. Let's see. Okay, let's see if that answer is correct. So that means we have the formula that says V is equals to IR. V, we know it's equals to 20 volts. What is I? I is what we are looking for. And then what is R? We just calculated it to be that. So now you're just going to divide both sides by that 3.67. 3.67, so that cancels with that. Then you've got your I, which is equals to, let's see, 20 divided by 3.67, which is equals to, this is what I'm getting, 5.45. Then it's A because it is measured in amperes. So let's see, maybe, let's see, what did the honorable member get on that one? Where are those comments? Charts? 3.33. Wait, is it me who made a mistake? Manga, let's compare honorable member. You got that and I got that. Is it me who made a mistake, or what's happening? Did you check and verify what you've done there, Manga? That 3 and 0. That, yes. But wait, guys, do you understand what I've done there on my calculation? Manga, let me know if maybe I'm the one. Sorry, I see where I went wrong. Okay. Okay. But guys, Zoom user and Chloe, why are you guys not commenting? Your answer does that you get, just comment, it is fine. We will look into that. Okay, then it's fine. Very quickly, let me then give you guys something to work it out. Let's see, we have that. I will then give you guys this one to work it out. I will do that then. I'll say 2 ohms there. Another one there. Okay, I will say that is the ammeter, and then again, let's say 20 volts there. And then I will say calculate the following. Number 1, R tot. Number 2, I will say ammeter reading, or the reading on the ammeter. Yes. There is a question that you guys need to work out. Let me check if you guys are able to clearly see there. Let's see. Guys, you can just comment in the comment section and say, did you see the question? Are you ready to work on it? I'm going to give you guys 5 minutes. Yeah, maybe 5 minutes, between 5 to 10. But I firstly need a confirmation from you guys to confirm if you saw the question. Did you guys see the question that you need to work out? I just need a yes in this case. Okay, there's Chloe saying yes. Okay, then it's fine. I'll go back to the question. You guys can try work it out, and we'll take it from there. Let me do that. Okay. Let's see. The first one is 3.20, 6.7. Okay. Okay. Based on that, I will have to continue. It looks like all of you guys did the calculations, not necessarily all, but those who commented. You did the calculations and you got the same answer. Maybe on my side, very quickly, let me calculate R tot, then I will know. So R tot, it will have to be let's see, 1 over that. Then you must plus it with 1 over that. I'm just working out the parallel. You must add it with 0.5. You must add it with 1.5. 3.2. Yes. Then you will say 20. You divide it by that answer of 3.2 and 6.4. Yes, that answer is correct. Let's see. Anyone struggling to find those answers? Because those answers are indeed correct. Let's see. Guys, anyone struggling to find those answers? 3.2 and 6 point something. Or are we all okay up to this point? I'll just wait to hear from you guys. Shonisani, are we okay there? Katleho. I saw Zoom user got the answer there. Okay. No. Let's see. I won't show my working. I need to know if you guys are getting that answer. So you see those answers are correct. So for me to know if you are getting those answers or no, that's what I wanted to hear, not me showing my working. Okay, then it means you need to try work it out on your side. If you fail, then you let me know which part you are getting wrong, then we take it from there. This one, it was meant for you to do, honorable members, not necessarily for me to work it out. You do it that same way I've shown you on the others. In case if you are failing, then I will know that you've given it a try and there's somewhere you are failing, then we take it from there. Okay, trust me, honorable members, in case if you managed to work out this part of calculating R tot and the reading on the ammeter, you are definitely getting somewhere. So now, let us do this other part of now trying to determine how much of electricity has been taken by these devices. Let us start with that one. Let us start with that one. So we can call this one V1. Then we will call this one V2. Then we can call this one V3. So to add on that question, they will say calculate the reading on V1 and V2 and V3. You know the formula most. You already know the formula. All that you need to do is to hone in on that formula. Again, I will give you guys a 3 minutes on this 105, and then from there we should be done. Okay, it looks like we still have some questions for art taught. Okay, while you guys work it out, let me quickly try to show these guys how you work out the R taught. So we said the formula for R taught is 1 over R, not R taught, but R parallel. Is that, then you'll say 1 over R1, and you plus it with R2. So 1 over, that one is 2, that one parallel, 1 over 3 being that one. Then you find R parallel by doing that. -1. Name. So what will be your R parallel? Then let's see, R parallel is 1 over 2 plus 1 over 3 to the exponent -1. So you will get your R parallel as 1 or a 1 comma 2 that. Nay. Then R taught, we said you just add all of them. That means you have this one of 0.5. You plus it with this one of 1.2. You plus it with that one of 1.5. Then the answer that you get, it is your R taught. Then to get the reading, you use this formula. V is equals to IR. You know this one is 20, and then this is what you're looking for. You just calculated this one as your R taught there. And then you just work it out. Exactly what I've done, honorable members. Exactly what I've done. Does it now make sense? Those wanted to see how you work it out. And let me quickly see. I think it's Katleho and Shonisani. Katleho and Shonisani. Did you guys get it? The last question, it just says V1, V2, and V3. You just use that formula of V is equals to IR. And then you know what the current is, the R, you check. Where is V1 connected? It's connected on the 0.5. Where is V2 connected? It's connected on the parallel. That means you use the R for the parallel. What about V3? V3 is connected on the 1.5. That means you use the current, the R for the 1.5. I've just given you a hint there. So now, let's see if you guys got something. Gatleho got it. Okay, goodest. Last question is V1, V2, and V3 is 100%. That's it. That's it. Now let's see. So we are now headed towards the end of our lesson for today. And I would like for you guys to just verify. Okay, I will then very quickly give some. So that means this one for V1, the formula we know most. We use this one, V is equals to IR. So what is I, the current? It's what you guys calculated. When it comes to R, you use the one for 0.5. Why? Because V1 is connected on that specific R. When it comes to this one of V2, you already calculated IMOS. When it comes to V2, you use the V2 for that parallel connection. Because this V2 is connected across that parallel connection. You don't use that one, you don't use that one, but you use the one that you got for the parallel connection. And then when it comes to V3, you know what the I is, you calculated it most. And then you can see that V3, it is connected on the 1.5 ohm. So that means when you take the value that you get for V1, you plus it with for V2, you plus it with for V3, it must take you back to that amount there. I think that's it, honorable members. I think that's it. Meaning, for now, we can just leave it here, honorable members, as I prepare for the next lesson with the grade 12s. Guys, did you all understand, honorable members? Did you have an idea of what I was referring to on those calculations? Understood. Okay, then it's fine, guys.